verbalize some stuff tonight?
I was just going to send you a picture right now. I was doing some other homework, so I forgot.
All right, that's fine.
Let me just take a picture here.
And the stuff we do tonight?
It's dividing...
by imaginary numbers?
No.
No?
Polynomials.
Oh, okay.
Hold on. Hold on, my phone's being stupid.
It's okay. Last week I wanted to take a picture out of my book for a student, and my phone died instantly.
Yeah.
Because it used the flash. It was in the email. And boy, if it doesn't have much charge, you don't want to take a picture with a flash.
Yeah.
Looks like you might have got it.
Yeah, there's like 3 pictures I'm sending just because all the ones I circled are the ones she wants us to do.
Okay. All right, we can just read off this.
Okay.
Hold on. So what's the answer to 1?
I don't know.
It's called the zero factor theorem.
Okay.
What it says is that if f of x, whatever polynomial f of x is, if it's divided by x plus 2, and x plus 2 is a factor, then it has to have a zero remainder.
Okay.
If it does not have a zero remainder, then it's not a factor. In other words, if I were to stick in some polynomial there like x squared minus x plus 2 and do the division, well, if this divides evenly into that, then it's going to have a zero remainder, right? And that's what we mean when we say is x plus 2 a factor of that, is it means that if you divide it into it, you'll get a zero remainder. And all true factors will give you a zero remainder.
Okay.
So it has a remainder of 0.
Okay.
Number 2, if g of minus 4 equals 0, then blank is a factor of g of x.
Is it negative 4?
It is. Negative 4 is the factor, by the same reasoning. In other words, if you plug in one of the factors, you always get 0.
Right.
Now, if negative 4 is one of the zeros, that means x plus 4 is the factor. So it would be correct to say x plus 4 is a factor of g of x.
Okay.
And minus 4 is therefore one of the zeros.
Okay.
What do you have to do to be able to divide these?
I don't know.
Well, how could I do this? In other words, we have a couple of ways we can do division.
It says how can it not be done using
Exactly. And one of the ways you do division is long division, right?
Right.
What's another way to do division? What's the other way you've been learning?
I don't know the name of it.
Synthetic.
Synthetic.
Okay. This cannot be done by using synthetic division.
Okay.
Because synthetic division requires you to divide by a linear term. You know how you set the box up and you put the coefficients across the top?
Yeah.
Like that? Well, I can't put a quadratic in there.
Right.
And that's what I would have to do if I was going to divide by x squared minus 2x plus 3. In other words, if I was dividing by a linear term, like x minus 3, then I could do that division synthetically by putting in a 3 right there, putting in the solution. But I can't do it synthetically if it's being divided by a quadratic.
Okay.
So they're saying if I take f of x and I divide it by x minus 5, which would represent this solution, has a what of 3?
Would it be a remainder?
Yes. It certainly does not have a remainder of 0,
Okay.
which would make it a factor. In other words, this is not a factor of f of x.
Okay.
If I knew what that polynomial was, it would not be evenly divisible by x minus 5. And I know because if it would be, then that would have to be 0, based on the 0 remainder theorem. Well, this is telling me that there is a remainder of 3. When I evaluate the original polynomial at 5, I get a remainder of 3.
Okay.
Okay? So if I divide this quartic by this linear factor, I get a cubic with no remainder. That means that linear factor is a factor of that polynomial. And it means that there also, because there's no remainder, x equal 3 is a solution to that quartic
Okay.
as one of the zeros. Okay? So they're saying that if I divide it by that, I get that cubic with no remainder, meaning that's a factor. And if I divide that same, well, if I divide this resultant cubic by x plus 3, I get a quadratic with no remainder, which makes what? Minus 3 also a solution. In other words, these two statements, up to there, right there, tell me that x minus 3 is a factor and x plus 3 is a factor.
Okay, so it factors into...
Well, let's write it. First of all, I know that that is equal to x minus 3 times x plus 3, both of those are factors, and the resultant quadratic, x squared minus 1. In other words, if I multiply that factor times that linear factor times that quadratic, I will get this quartic.
Right.
Because this x times this x is x squared times that x squared is x to the 4th. And all the other terms will work out also. And I know that because they told me that this original cubic is divisible by that with no remainder. So I know that's a solution.
Right.
And that solution is divisible by x plus 3. So I know that that's also a solution. That's a solution not only of this cubic, but also of the quartic.
Okay.
Okay? That's what they're essentially saying, is that the original quartic has these two linear factors. Now, it's not fully factored yet. It said, right, it factors into, well, I got it that far. What else can I do with that? Can I factor it anymore?
No.
What's this called?
I don't know.
It's called the difference of perfect squares.
Oh, right, okay.
How does that factor?
A plus B.
You know what? Remember it as A minus B, for starters.
Okay.
And the reason is that it's not that it's not right. In other words, you were going to say this, and that's perfectly right. But it makes it difficult to memorize the difference in sum of squares if you do it this way.
Right.
In other words, by memorizing the negative term first, now you're set to memorize difference of cubes and difference in sum of cubes. Why? Well, let's talk difference of cubes. Difference of cubes, the very first term is that same linear term, same sign, minus b. The next term is a quadratic with a different sign in the middle.
Right.
And then we have the sum of cubes. Well, what is this first term? A plus b. Same sign. So notice what all of these have in common is the very first term is the same sign as this. That's why I want you to memorize it as a minus b times a plus b.
Okay.
Because it makes it easier to memorize difference and sum of cubes. Because there's a pattern to all three of them now.
Right.
Notice what the pattern is. And you do have to memorize all three. Well, maybe you don't. You have to memorize difference of squares. They may let you use a cheat sheet on difference of cubes and sum of cubes. But they expect you to know this one here.
Right.
So what does x squared minus 1 factor into?
X plus 1 minus
I'll
1.
do it in the right order.
Minus 1. X plus 1.
Okay. Okay? I want you to do it in the right order because it'll help your memory of memorizing this.
Right.
That's the only reason. So now I can factor this thing into x minus 3 times x plus 3 times x minus 1 times x plus 1. There are the four factors to that quartic. Number 6. Hold on. You like synthetic division or long division? It looks like
We've been
both.
doing, yeah.
Let's do long division
Okay.
for these problems. It looks like they want you to do long division. Based on number 8 and 9, it looks like 6 and 7. In fact, we can do both. We can do it long division and we can do it by synthetic division. So I'm going to divide x minus 3 into x cubed plus 2x squared minus 6x plus 12. Tell me what the first thing I want to write right there is.
X squared.
Okay, now what?
And then you do x squared on the bottom.
Well, you multiply x squared times both of these terms.
Yeah.
Well, x squared times x gives you x cubed. X squared times minus 3 gives you minus 3x squared. Now what?
Then you subtract them.
Okay, what do you get after you subtract?
The x cubes cancel out.
Always?
And then
Okay.
negative x squared.
No. Remember, you're subtracting. I have a 2x squared minus a minus 3x squared.
Oh, it should be 5x.
Squared, yeah.
Right.
Now what?
Then you bring down negative 6 and 12.
Not both, just one.
Okay.
One at a time. And now repeat.
And then
What goes here?
5x.
Yeah, so all we're doing is dividing that into that.
Right.
Get this next term. We're ignoring the minus 3 and the minus 6x. So x goes into 5x squared,
5x.
5x times, and then multiply by both. What goes down here?
5x minus 15x.
5x squared minus 15x, okay?
Right. And then those cancel out. And that would be negative, that'd be positive 7. Right? No, 9.
9. Now
And
what?
then plus 12.
Okay.
And then, I don't know.
Well, do the same thing we've been doing. We've done it twice already in this problem. Divide that into this.
Oh, okay. So,
In other words,
9x.
this is an iterative process. Just keep doing exactly the same thing
okay.
until we have a remainder. Okay, so what goes up here?
9.
Plus 9. Because we need a sign. I can't not write that sign.
Right.
Okay, now multiply.
That'd be 9x plus minus 27.
Subtract.
Would be positive 39.
Okay, we got a 12 minus a minus 27.
So it'd be 12 plus 27. So 39,
Okay.
I think.
Yeah.
Yeah.
And it doesn't have an x anywhere. We've
Right.
gotten rid of all of our x's. That makes that the remainder. We have
So
a
then,
remainder of 39, and technically the remainder is 39 divided by x minus 3. So that's the answer. When you divide that polynomial by x minus 3, you get this quadratic with a remainder of 39. And whether she
Right.
wants your remainder as 39 or 39 divided by x minus 3, I'm not sure.
okay.
Technically, I would go ahead and say 39 divided by x minus 3. Because,
Right.
here's the thinking. In other words, after we're done, we should be able to take this answer, including the remainder, multiply it by x minus 3, and get that polynomial. Right? In other words, if A divides into C and gives you B, then A times B equals C. Well, if it gives you B plus a remainder, then A times B plus that remainder equals C. But that remainder is actually R over A.
Mm-hmm.
So the full remainder is always that number divided by the divisor.
Okay.
So she probably wants 39 divided by x minus 3 for 6.
Okay.
All right, let me move that over a little bit so we can do 9. Not 9, 7.
Right.
Polynomial. And so far we haven't had any missing x terms. If we did, we'd have to use a dummy variable. In other words, if this didn't have an x squared, let's just say it was like that, I would have to put in 0x squared there in order for the long division to be able to work. Okay?
Right.
Okay, you do it entirely this time.
Okay, so the first thing you do is you put x squared on top and multiply x minus 3 times x squared.
Okay, yeah, you just give me the line. You don't need to tell me what you're doing even.
Okay, so it would be x to the third minus 3x squared.
Next line.
And then you subtract those and you get 2x squared, and then bring down minus 7x. And then you multiply x minus 3 times 2x.
Divide, you mean?
Yeah.
In other words, we're now dividing that by x minus 3.
Uh-huh.
Okay, so what
So
goes
then 2x.
plus 2x?
Yeah.
Because I have to have a sign with it. I can't. That's not a plus sign I could ignore. I can ignore this plus sign. But once I divide it and it becomes part of a polynomial, I need a sign on it. If I leave the sign off, that's what I'm looking at.
Mm-hmm.
Well, I got to have a sign. Okay. Now what?
Then you multiply x minus 3 by 2x.
Okay.
And get 2x squared minus 21x.
No, you're just multiplying 2 times minus 3.
Okay.
Right?
Right.
In other words, where'd you get the 21 from?
I
multiplied 7 times 3. You know,
Yeah.
multiplying that times the minus 3.
Oh, right. Okay.
Which makes
So that would
minus
be
6x.
minus 6x.
Subtract.
That would be that would be 1x.
I have a perfect program for you.
Negative 13.
I have the program that I have been looking for 3 years. And I've never found it until about a week ago. It's called A+ Math. And it's the only one I have found that lets you do positive and negative numbers.
Okay.
Do these for me. Spend 5 minutes a day on this and it'll work wonders for your arithmetic skills. Do these as fast as you can without a calculator. If you have a calculator, set it aside while you do these.
I don't get what it's asking.
2 times minus 9.
Oh, that's times. That's negative 18.
Right. No, they're a little weird that way, but that's division there.
That's 9. Is that multiplying or
That's
dividing?
division also.
2. That's 11.
Try again. Try again.
9 minus 3.
Which is the same as 9 plus 3.
12.
Okay.
That'd be negative 5. That would would be -9. Right?
If you are adding, we have a positive 4 added to a negative 5. Positive 4 added to a negative 5.
Be -1.
Okay. When you add a positive to a negative, you always subtract the two numbers to come up with 1, and then you put the sign of the larger number. Well, if 5 is larger than 4, it has a minus sign. There's my sign. Okay? So, what's -7 minus a -6? In other words, this appears to give you a little problem because there's so many dashes there. It's -7 minus a -6. Well, that's the same as -7 plus 6. What's that equal to?
-1. -1.
Yeah, exactly. Hold on. Hello? Hi, Jill. Listen, I'm in the middle of a session. That's fine. I'll talk to him tomorrow. Okay. Sure. Bye-bye. All right. Well, still with me?
Yeah.
Okay. Okay, so let's see. Back to this problem. So when we subtracted a negative 6x from a negative 7x, I got minus x, not plus. And I bring down the 3. Next step?
Then you do minus x. No, you do -1.
Good. Go ahead.
And that would be negative x minus 3.
It's -1 times -3.
Positive 3.
What's that equal?
Then it'd equal to 9.
0.
Or 6. I can't. I'm
6.
brain dead.
3 minus 3 is 0. So
Oh,
there's
right.
no
I'm
remainder.
so brain dead.
So there's no remainder. Which means that's a perfect factor of that polynomial. The remainder is 0. Because it's a remainder of 0, it is a factor. And
Okay.
I can now say that x minus 3 times that quadratic is equal to this cubic.
Okay.
Okay? Now,
Yeah.
you've got to explain something to me,
Yeah.
because I'm noticing it with about 5 different students. When I'm doing stuff like this, everybody gets their positives and negatives mixed up.
Right.
The moment I take the student to this, they do almost perfect.
I don't know.
What's
I
with
can't
that?
tell.
Let's go through a few more of these. What's this one? I want to make sure you can do these perfect as it seems like you can.
-1.
Hold on. I gotta be in the box.
Is that multiplying? Yeah, it's
Yeah.
minus 80, negative 80. That would be 3.
So does it matter that there's a variable?
No.
I wouldn't think so. In other words, when we're doing all of these, it's minus 7x minus a minus 6x. So we have a variable attached. But that doesn't mean, in other words, you can ignore that variable. That's why synthetic division works. Variables, you don't need them. The only thing we ever work with is the constants, or the coefficients, rather. And that's why synthetic division works. We synthetically divide by +3. That allows me to take out all the variables and add instead of subtract. That's why synthetic division works, is that you're basically changing it to addition problem instead of a division problem.
Right.
Let's keep doing these.
Okay. That would be minus 17.
This is multiplication.
Oh.
Addition, addition, you would have been correct.
Okay. It would be 70. Then that would be 3.
See, you're perfect. You do it. You're not going to miss any of these like this.
Yeah, that'd be negative 14, 15.
Just as I spoke, you had to do that. Okay, let's go back. So far, we've seen that there's a problem when you have a negative number and a positive number. Well, that's what we have here. Is we have, naturally my computer stops working right as I say that. Okay. What was the problem? We had a negative 8 added to a positive 6. So a negative 8 added to a positive 6. So just remember the following thing. When you're adding a negative number to a positive number, doesn't matter the order they're in. In other words, this is the same problem. I'm adding a negative number to a positive number. Subtract the two numbers and put the sign on of the bigger number. Well, if I subtract the two numbers, I get 2 in both cases. But the sign of the bigger number is negative up there. The sign of the bigger number here is negative. So that's the answer. So remember, when you're adding a negative number to a positive number in either order, you have to subtract the two numbers. It becomes a subtraction problem. That's all. So this is negative 2. I wish I would have found this program 2 years ago. I'm serious.
Yeah.
It would have made a huge difference. Now, I can't force you to practice on this thing. Incidentally, you'll notice it's called A+ Math, so it's pretty easy to remember. Okay? If you spent 5 minutes a night for a week on this program doing exactly what we're doing now, you would not believe how much difference it'll make to your math skills. And I'm not kidding. I believe that more than anything in the world. That this is so much more important for you to be good at than knowing that parallel lines have the same slope, even.
Yeah.
This is where you stumble, is in the arithmetic. It isn't in the concept. It's always in the arithmetic that I've seen. So what's this?
That is 15. That is 13.
7 minus 6.
Oh, that's 1. Sorry, I thought there was 2 minus signs.
Okay.
It's hard for me to see because it's small.
Yeah, no, I get it. I get it. Yeah, okay.
Negative 24.
All right. All in all, you're much better at these flashcards than you are when doing algebra.
Yeah.
What's this?
That is
You're adding a negative number to a positive number.
Negative 3.
So you subtract the two numbers, you get 3, and then you put the sign of the bigger number on it.
Okay.
You don't have as much trouble multiplying and dividing.
Yeah.
It's adding and subtracting with positive and negative numbers. Let me do this. I'm going to copy and paste this link into the chat window. There, you see it in your chat window?
No.
Oh, you may need to open up your GoToMeeting window panel. Click on that orange arrow.
Okay.
Now do you see it in the chat window?
Oh, it says like right here.
Click on that link.
Okay.
Should open up the same window on your computer.
Yeah, it does.
Save it as a favorite.
Okay. Alright, it's saved.
Whenever you get really bored and you want to work on your math skills, do these and see how fast you can go through them. That's really what it's all about, is seeing how fast you... They even have timers on some of these. I didn't turn the timer on, and you don't worry about the speed until you get 100% accurate. Once you get 100% accurate, then you can worry about doing it faster. But get to a point where you can do 10 of these in a row without making a mistake.
Okay.
It's kind of like great golfers. You know who Tiger Woods is. Well,
yeah.
Tiger Woods will not leave a putting green until he has made 100 consecutive 4-foot putts. Because he's supposed to make every 4-foot putt he makes. So he makes sure he does 100 in a row before he quits practicing. Okay? If your life depended on your arithmetic skills, then I would say do these until you can do 10 in a row. Don't stop practicing until you do 10 in a row. 10 in a row. The moment you get 10 in a row correct, you can stop practicing for the night.
Okay.
But if you want to really improve your math skills, that would be a great little exercise to do.
Okay.
Just do these until you do 10 in a row. If you do 9 and you miss the 10th one, then start all over again until you do 10 in a row.
Okay.
All right, I'm going to close that out. Oh, here's your math questions right here. All right, let's see. We got 20 minutes. We did 7, right? So we need to do 8. And find the missing information. Okay. Well, finding the missing information is the same as this problem up here. Right?
Right.
Except we're dividing by x minus 4 instead of x minus 3.
Right.
So the way
first one would be...
You don't even need to pay attention to any of this stuff down here.
Right.
Just duplicate it.
Right.
So x squared. Now what?
Minus 6x. Right?
Hold on. Let's go through the long division of it. In other words, tell me what I need to write right here.
X squared, or cubed. Minus 4x squared.
Okay, good chance for you to practice your subtraction skills.
Right, and it'd be 6x squared. And then you'd need you need positive 6x. And then multiply that and be negative 24x. And then that turns into 18x plus 12. And then you need 18x
Plus
18x.
18, not 18.
Or just plus 18.
Plus 18.
Right.
Because remember, when we multiply this by that, we got to get that.
Right.
Okay. Let's go ahead and multiply that in case there's a remainder. And there is. So what's the remainder?
84.
Okay. And the remainder 80. Now, does your teacher write remainder of 84 like this, or does she write remainder of 84 divided by x minus 4? if you're going
The
to call it,
second, I don't know.
well, you know, I just start thinking about it, and if you're going to call it a remainder, then it's probably just 84.
Right.
If you're going to represent that as a fraction, then it's the answer is x squared plus 6x plus 18 plus 84 divided by x minus 4. In other words, I can make that look like this, plus 84 divided by x minus 4. And technically that's the correct answer. This is the correct way to do it. But if you're just going to list the remainder, then you probably don't need the divisor.
Right.
All right. Did you do this one? Oh, no. Okay, this is a little different. So we need to figure out what that would be.
That would be x plus 2.
Well, let's see. That would give us x squared, x cubed plus 2x squared, 0 minus 6x. It's not x plus 2. What is it? How did we get this right here? In other words, we got this by multiplying x squared by some linear factor. Well, what must it have been for me to get this? X plus what?
X plus...
X squared times x plus something equals x cubed plus 3x squared.
Oh, plus 3?
Yeah.
Okay.
In other words, if that were a 3, then I would get x cubed plus 3x squared, which is what we're looking at here.
Okay.
So that's the only thing you need to do is divide x squared into x cubed plus 3x squared to get x plus 3.
Okay.
And you don't really need anything else. The moment you figured that out, that term alone, you're actually done with this problem.
Okay.
Okay?
All right. Number 11.
Okay. Now, where is that? I don't really have that on this page.
I sent you a different picture.
Okay. Describe and correct the error. Well, let's go through 11 and see if you can figure out where the error is.
Okay. Oh, I can see it right now. They added -8 plus -3, and that's how they got
What
11.
should that be?
That should be -5.
Good. Okay, well, we're done with that. How about 12?
I don't know.
This term right here. Oh, hold it. No, I'm looking in the wrong place.
Mm-hmm.
No, that's correct. When I subtract, I get minus x squared minus a minus 8. That gives me 7x squared.
Oh, they didn't.
3, 7x, multiply.
Is that for number 12?
Yeah, there's one mistake. This right here. No, that's even correct. There is no mistake in this one.
Well, yeah, there is, because on the inside, That's what you're dividing by, and they didn't put a term for just x. They only have x squared and not x. You need a value for just x.
No, hold on. X cubed times that is x to the fourth minus 2x squared. This is correct. Oh, it's missing the x. That's what you meant.
Yeah.
Ah, so let's do this one correctly, since this is the first one we've seen like this. This is the one where you got to use the dummy variable.
Right.
So I got to write this. Plus 0x plus 3.
Mm-hmm.
All right. Now do it. Wow, good catch. Good catch. I missed that.
So it'd be 4x minus 2x to the third. And then you subtract that and get 4x to the third.
Well, 4x squared.
4x squared. And then you get 4x to the third minus 2x squared.
Hold up. Multiplying this times that.
That'd be negative 8x squared.
Okay. Next.
Then you subtract those, and you get 7x squared. And then you need to drop down x.
Drop down the 0x.
Right.
Now what?
And then you need, it'd be plus 7x.
Okay.
So then that would be 7x squared minus 14x.
Okay.
And then you subtract, and then that would be 15x.
What's 0 minus a minus 14?
Negative 14, sorry.
Hold on. 0 minus a minus 14.
Positive 14.
Okay. X. Bring down the 3.
And then drop down the 3.
And now repeat.
And then you need plus 14.
Okay.
14x.
And 14 times x minus 2 gives you 14x minus 28.
Mm-hmm.
What's
And then you subtract 3 minus negative 28, 31.
good? And that's the remainder.
Right.
All right. Is there another one on this page we need to look at?
No, I sent you a third page.
Yes, I got it.
Page 17, 18.
All right. Okay. Again, we can't do this by synthetic division because we're dividing by a quadratic, so we have to do this the long way. Well, not really the long way, the long division.
Okay.
And there's no missing x's. All right.
Nope.
Take it away.
Okay, so the top one would be 8x. And then it'd be 8x to the third minus 24x.
Whoa. Whoa. Hold on. Hold on.
I'm confused.
I am too. I am too. Just realized I don't know how to do this.
That's weird.
I've never seen a polynomial divided by a quadratic like this, and what to do when you run into this problem. In other words, we can't subtract, or can we? Huh. Do you know what we're talking? She may have gone over this in class with you.
She did not. I'll ask her that on Wednesday morning.
Well, let's see if we can figure out what it is. We got a few minutes here. Is this the last problem you have to do?
There's 18 as well.
Just look at 18 real quick. See if there's anything different in it that we need to attend to. No, it's the same problem. It's dividing by a quadratic.
Mm-hmm.
The question is, what do you do when you divide by a quadratic? Let's see if we can figure out. Can't be that hard to figure out. Let's see. If, now let's go ahead, it's got to be that. Now the question is, when I subtract, what do I get? I get 5x squared minus a 0x squared. So I get 5x squared, and then I get,
Wouldn't you just get
minus 24x or plus 24x?
Yeah. Or would you plug it into the quadratic formula?
No, you wouldn't do that. The quadratic formula is for factoring a quadratic.
Well, what if we factored the quadratic first and then plugged it in?
Well, we could do that. But the problem doesn't, oh yeah, that's how you do this problem. Very good. Very good. X squared minus 3 is what? Difference of perfect squares. Wow. That really makes the problem hard. In other words, that's what x squared minus 3 is, right?
Mm-hmm.
Well, now I can divide each one of those separately into this cubic.
Mm-hmm.
And that'll work. It results in a really nasty answer. In other words, I start by dividing that into the cubic, and then whatever answer I get, then I next divide that into that answer.
I'm confused. Dad.
Well, wow. That's the way to do it, but I can't believe that's what they want you to do.
Mm-hmm. Why would it be root 3?
Well, because all these years where they called this difference of perfect squares, it doesn't need to be perfect. In other words, if a squared minus b squared equals a minus b times a plus b, well then I can factor x squared minus 3. What is that? That's x minus the square root of 3 times x plus the square root of 3. You see that?
Yeah.
Okay. So I can break that x squared minus 3 up into these two factors.
Right.
And then, well, it clearly is correct. If I have something divided by two things, well, I can write that like this. Divided by x minus root 3 Is this not the same problem? It
It
is.
is.
So now what I'm going to do is I'm going to divide this by this. Since I'm dividing a cubic by a linear, I will get a quadratic as an answer. And then I will take that quadratic and divide it by that. And I will get a linear answer for that.
Okay.
In other words, I will end up with this cubic being 3 linear factors.
Right.
2 of them being that.
Okay.
And by the time I do this long division twice, remember I have to do this into this. Whatever I get, it's going to start out looking like that. Okay. So whatever the final quadratic is, then I divide it by this. Another linear term. And everything works nicely. Now, there may be a better way to do that division. In other words, there may be a way to do this where you don't have to separate this already into 2 factors.
Yeah.
Just, it wasn't until this moment right now that I didn't realize I didn't know how to do that.
It's fine. I can ask her tomorrow morning, too.
Do ask her. I'm curious whether there's a way to divide that directly or if you have to factor it first.
Okay.
Okay? All right, Taryn.
All right. Have a good night. Thank you.
You too. I'll talk to you next time. Let's see. Did we change our regular or did you make this online? No, this was a regular. I think this is our regular, right? 5 o'clock on Monday? I'll see you next Monday at 5.
Sounds good.
Bye-bye.
Bye.